All right, everyone, we're going to get started. Thank you so much for joining us today. Welcome to the latest installment of the GoAERO Expert Lecture Series. GoAERO is sponsored by our amazing partners, including NASA, Boeing, Pratt & Whitney, and so many other organizations around the world. Today, we are absolutely honored to have with us Rex Alexander. Let me give a quick introduction here. Rex is the person that I think we would all like to have with us in an emergency. Rex Alexander is the founder and president of 5 Alpha. He has over 4 decades of military aviation, general aviation, and commercial aviation experience as a pilot, A&P maintenance technician, safety professional, and is a globally recognized subject matter expert on vertical flight instruction. He is the founder and president of the aeronautical consulting firm 5 Alpha, which is dedicated to providing specialized education, research, and insight into the very challenging and unique community of vertical flight instruction. Rex has served as an infrastructure advisor to the Vertical Flight Society since January 2019, is chair of the National Fire Protection Association, 418 standard for heliports and vertiports as technical committee, is co-chair of the U.S. Helicopter Safety Team, Infrastructure Working Group, is a member of ASTM International F38 WK 59317 new specification for Vertiport Design, is a member of the Vertical Aviation Safety Team Technology Working Group, and is a member of the Illuminating Engineering Society Airport and Heliport Lighting Committee. And so many more. He is an alumnus of Parks College of Aviation and a former U.S. Army warrant officer, an Aeroscout helicopter pilot, instructor pilot, and standardization instructor, having served both on active duty and in the Indiana Army National Guard. So as you can see, as I said, no one you would want more than Rex Alexander at your side during a crisis. And with that, Rex, I will let you take it away.
Oh, you make me sound so impressive. With that and $1, I still can't get a cup of coffee at Starbucks without spending a lot of money. But the piece that you're probably most interested in is not what she talked about, is more about the experience I had for 20 years as a helicopter air ambulance pilot. So in that space, I was a pilot, I was a base manager, I was a regional manager and a safety manager, and worked with a lot of education and training with first responders in dealing with not only hospital to hospital response, but really spent a lot of time with first responders in scene response and dealing with how to do this safely, what to deal with, what are the go, no-go decision-making parameters, and so forth. So with that, I'm going to go ahead. I have a few slides here, high level, but as I told Gwen, I said, these are the things that are going to get you and the patient killed. And these are the things you really want to pay attention to before you even get in an aircraft or send an aircraft to a scene. And this is based on 20 years of everything that could go wrong that did in my life and in my career. So with that, I'm going to get into this. So this is emergency scene response basics based on the parameters set forth by this GoAERO prize. Some of this is going to be intertwined with the criteria that is in the documentation you've been provided by GoAERO. I've added some other things in here to think about, specifically going forward. If this is something that you're looking at a long term, there are some specific areas that aren't talked about in the Go Prize documentation that you need to pay very close attention to. So first, we always get into this. This is a Hippocratic Oath, first do no harm. So we always, as a pilots and the EMS crews, the nurses, medics and such, what's the best thing for my patient? And sometimes, I hate to say it, but sometimes that's not actually going to pick them up. Sometimes the patient's too unstable or the weather's such that it's too dangerous. So we have to look and say, what's my litmus test? The litmus test for anything you do when somebody's injured is what's the best for that particular patient. And then from there, make your decision matrix going forward, but do no harm. There's a couple references that I want to kind of point to that are good guidance documents if you're looking at this space from a business model. So there's the Helicopter Air Ambulance Guidance. What's the FAA Advisory Circular AC 135 14 Bravo. There's the link there, and I'm guessing we'll provide the slides at some point too. But this is a good document to look at and see what the criteria and recommendations from the Federal Aviation Administration on carrying out helicopter ambulance operations are. Additionally, landing off-site. So the group down on the bottom right corner, the National EMS Pilots Association, back in the late 80s, early 90s, actually created what they called a landing zone guidance. The FAA liked it so much that they actually incorporated into that document you see on the right, which is the Federal Aviation Regulation and Aeronautical Information Manual. If you look in Chapter 10 under Helicopter Operations, Section 2, Special Operations in Section 2-3, Landing Zone Safety talks about safety protocols and procedures for setting up a landing zone. This is what we point first responders to when they're having questions about, well, I'm bringing in an aircraft, what do I need to do to set up the landing zone? This is a great resource. I was board member of the National EMS Pilots Association for a long time and even spent 2 years as the president of that association in a totally another lifetime. One of the first challenges we run into is communications. Now you have to kind of look and see who you're doing business with and figure out what it is you're going to be working with them on as far as the infrastructure. Up at the top, you have the basics. So VHF and UHF are the approved primary radio frequency bands that we find EMS in. Then the next one down is the 800 megahertz system. And then if you're working really closely with military, you might see some entities out there in the FM band range. Now, all these put together, some of the problems you run into is specifically in the VHF, UHF is simplex versus duplex frequency. So you're communicating whether it's manned or unmanned. Maybe you're doing a retransmission from the aircraft to the site, being able to communicate. Simplex basically means there's one frequency, transmit and receive on the same frequency. Duplex means there's two frequency involved and more than likely a repeater. So if you don't have both programmed, you're not going to talk to each other. So you have to do your research on who you're working with in your backyard. What are they using? The next one there is a continuous tone code squelch system, or CTCSS, also known as PL tone codes. There's a lot of communication traffic on some of these frequencies in these bands. And what they do is they put in that squelch code, which is basically a piggyback frequency, so that you can't hear that unless the individual calling you has the appropriate tone code, which is basically another frequency. You'll hear people say, hey, you can hear us, but we can't hear you, or we can hear you, but you can't hear us. That's the problem. Now, if you're working in 800 megahertz by chance for your system, that's a proprietary system. So that's something that you, an individual, can't pre-program. You have to get a manufacturer rep to come in and actually put that in your system. And you have to get authorization to use that system, where VHF and UHF, you can pre-program that all day long. And then the FM military, that usually requires letters of agreement and working directly with the military in some cases, not all cases. So communications has always been one of the bugaboos about EMS, not being able to talk to each other. And one of the key elements there is per the federal regulations under Part 135, and the way the FAA addresses this for this type of operation is through the operation specifications, the op specs, and the special criteria. In most cases for EMS, it says that you can't land until you have communications with somebody on the ground. So this can keep you from landing. You can't just land if you want to without being able to talk to that first responder. When you're taking off, one of the things we're always looking at is general patient information. We don't get names, we don't get ages. Patient weight is critical. You're going out to pick somebody up, and having been there, and you show up and the patient's 200 pounds heavier than what you were told, and all of a sudden you don't have the ability to move that patient because the aircraft doesn't have the performance. Maybe it's a really hot day. Maybe you don't have the capability to get them out of the location they're in. So having the patient wait helps you make a good decision. And that's one of those key elements that we always want before we lift off. Then we look at what kind of injuries or illness is associated with this patient, because you may actually have to take additional equipment. So when we take off, we don't want to show up and not have everything we need. If it's a burn patient versus a cardiac patient versus a neonatal patient versus a trauma patient versus a drowning patient, each one of those cases may require additional equipment. So it's always, behooves you to get additional information on what's going on. The one that we look at in trauma that I've had challenges with in the past is accidents where there's been a foreign body penetration. That's been upwards to a 4x4 fence post of like 9 feet. You're not going to be able to transport that until you deal with it. Dealing with it means cutting off either end, not pulling it out, but cutting it off. And can you do that? Can you do that safely? Good to know before you walk into this situation. And then what's the stability of the patient? Normally we transport unstable patients, but there are a certain class of unstable patients that you just don't want to put in an aircraft because of turbulence, vibration, or the criticality of the patient. One of the ones I would point to is patients that are pregnant and in labor, active labor. We never transport active labor because there's no way you can take care of both patients if that individual actually delivers in the aircraft. So those are some of the key elements that we look at and think about before we even start the aircraft and head in that direction. En route, one of the things we look at is when we get to the site is being aware of your downwash and outwash. Now, this is twofold because where your downwash goes, it's going to then hit the ground and push out. Once it does that, it's going to have a huge influence on the surrounding area. And if there's anything in that area that's loose, and when we're talking, I'll show a little bit here in a minute, debris is then going to be blown around and it can injure people on the ground. It can also, if you're dealing with anything that's loose enough that it can recirculate into the downwash envelope, can cause damage to your aircraft to the point where it can make it unflyable or you can have an accident. And that has happened. Trash bags, get them wrapped up in the tail rotor. Per federal regulation, once a foreign object enters the aircraft, it requires an airframe and power plant mechanic's sign off before it can fly again, whether there's damage or not. So you've just stopped that transport in its tracks. So being aware of where your downwash is manifesting under the aircraft, where it is trailing behind you, and what the impact that's going to have on the environment you're going into is huge for the safety of the people on the ground, as well as the safety of the aircraft itself. When we look at debris, one of the things that some first responders may do is they'll put the landing area too close to the debris field. So you see all the debris in this picture. Imagine hitting that with the high volume of recirculated wind off of a helicopter or a UAS or something like that. Now we have objects in the air that could cause harm or they could cause damage to the aircraft. So when you're coming in and looking at the location for landing, you're evaluating the location based on the debris field and making sure that you don't place your aircraft in a situation where you could potentially cause harm, damage, or injury. Now, that said, we look at particulate debris. Brownout and whiteout are two issues that we deal with a lot of times in the industry in different locations. So environmental conditions are going to play a huge role in some of the decision making you're going to make. Having worked in the desert environments in New Mexico, Arizona, California, brownout, yeah, it happens, and you have to plan for it. And there's ways to plan for it. It's going to require you to slow down and not just shoot your approach in there. We've used water to wet the area if it's available, just lightly enough so we don't have the brownout. Whiteout in snow environments, the key there is you may be able to wet it, you may not be able to wet it, but in both cases, it's a visibility thing. Can the aircraft maintain control and stay within an envelope that you set for it when these two occurrences happen. If not, you need to have a plan in place that if this occurs, what are the steps that you take to exit that environment without causing an accident or an incident? And that could be different things for different configurations. But this is something that I've dealt with. I've gone in total brownout. I've gone in total whiteout, either landed directly because I still had the ground in sight, or if I lost total ground, executed an instrument takeoff, climbed out, came back, circled, waited to the dust to settle. And also keep in mind when you're dealing with either one of these cases, we'll talk a little bit more about another cases considering hazardous material, is where's the wind? Where's the wind taking this? And what's the impact of your rotor wash to the environment? Because the last thing you want to do is dust the entire first responder team and the patient off with whatever is there that is causing this issue. Now we get to wind. Wind is one of those things that we are very cognizant of, because if you can land and take off into the wind in a helicopter, it behooves you from a power requirement. Your performance is much better into the wind. And I've experienced that a lot of times where just, 5 knots of headwind can mean the difference between getting in and getting out. And knowing how to judge the wind, and this is just a chart from the National Weather Service that I pulled offline, that this is what we teach general pilots on where's the wind coming from and what's the velocity. And if you can pick up on the cues of your environment, you can kind of get an idea. The key element in landing at an offsite location where there's no windsock is look for cues. It could be smoke, it could be trees, it could be flags, it could be almost anything, dust. But keep in mind that where you're landing is probably going to have a different wind direction than what you're experiencing at altitude. The difference between a 400 or 500-foot elevation and ground surface elevation can be upwards of 90 degrees because of the topography and the geography impacting the wind direction and the flow pattern. So always don't just say, hey, I'm experiencing winds out of 090 at 10 knots at 500 feet. Well, you may get down to the ground and all of a sudden, yeah, it's no longer that. It's the winds are 330 at 15 knots because it's being accelerated around a mountain peak. So pay attention to that. Make sure that you identify what the winds are on the ground. And first responders, when you look at that guide in the Aeronautical Information Manual, first responders know that they're to identify the 4 corners of the landing area. They're supposed to put a 5th flare or cone or light on the side that the wind is coming from to help the pilot see where the wind is at the site. Not everybody does that. It does happen. But the wind's going to help you or hurt you. So know what the limitations of your aircraft are. We as helicopter pilots avoid any downwind operations to the extent that we can. Crosswinds aren't bad depending on the wind velocity, but we always want to try to put it into the wind as much as we can. Now, wind is a part of this, but the turbulence is another part of this. So if you're in a rural environment with a lot of terrain, pay attention to the turbulence generators. That could be tree lines, that could be ridge lines in the mountainous regions, the mountains themselves. We get into the mountain wave and the turbulence regions, which are invisible. So you have to know what you're getting into beforehand. So a good recon before going out of a map and looking at what the differences are in elevations, looking at the prevailing winds, and then you can determine, okay, we expect to have issues in these areas is great pre-flight planning. In and around buildings, the picture on the bottom right there is a wind tunnel of an actual heliport on top of a building. And if you're picking up a patient, this is where you're going to take them to. You see the recirculation zones on the front of the pad. This has a 6-foot air gap and the wind is coming up over the top and actually dumping on the pad. We got rid of that by raising it up to 8 feet. But in this case, if the pad was at 6 feet or on the building, there's a downdraft right on the pad. Downstream, you're coming into the wind, so you're coming left to right. You're going through this recirculation pattern. So you're going to get a headwind, a downdraft, an updraft, and then a downdraft, all in succession. It's a really rough ride, and several helicopter pilots have experienced bent skids because of it. So understanding the aerodynamics of turbulence generators and architecturally induced turbulence as well as naturally induced turbulence is important. Obstructions, when you're going off site, you understand that there's obstructions. When you go to a heliport, you would hope that there wouldn't be obstructions that you would worry about, but I will warn you right now, there are obstructions because not all heliports meet standard. What are obstructions? Power lines, trees, antennas, buildings are all obstructions that you have to pay attention to. When you come in for a landing, you're first identifying obstructions. We call that the high recon. Once you have established where you want to land, where the wind direction is, align your aircraft with the longest axis into the wind and set up final approach, now you're actually starting your low recon. Low recon is validating what you did on the high recon, calling out the identified hazards on the way down and reevaluating the entire way to make sure that you didn't miss anything. Up on the right, you see an aircraft that tangled with a power line. Luckily, they didn't, no one was injured, but did some serious damage to the aircraft. You see the power line wrapped up in the vertical fin there in the picture. And the rule of thumb that we always live by is if there's a road, there's a wire on it, period. Just treat it that way. That's a good safety mindset. Just expect wires to be there, period. Now, when we get into aircraft performance, the key there is account for the changes in the environment. So you may have taken off and expected to show up for a patient that was 150 pounds, and you get there and the patient weighs 200 pounds. You took off and they said, oh, we added some equipment on board. We need this piece of equipment for the patient. That's an extra 20 pounds. Oh, we got there and we're landing in a hole and the obstructions are all the way around at 50 feet. Now I have to have a higher performance margin from my aircraft. I'm going to ask my aircraft to do more than I thought I would have to do. Increased density altitude, increased air temperature, changes in the wind. All these things are going to occur in different time zones, i.e., it's not going to stay the same. From the time you take off, the time you arrive, and the time you leave, every one of these can change significantly. And when you experience a delay, and a delay is we showed up and we can't transport right away. A good example, you got there and the patient's still entrapped. It takes an hour to get the patient out, get them stabilized and ready to go. I was on a trench cave-in for 4 hours one time. Temperature changes, wind changes, weather changes. You have to make sure you're keeping track of that because what you could have done 4 hours ago, you may not be able to do now. So making sure you pay attention to change and paying attention to all those things on the right and knowing what your aircraft is capable of doing in all those situations is huge. Now, we talked about debris, but another piece of this is hazardous materials, or we'll refer to and you hear as hazmat. Question we always ask before we ever head out the door, is there any hazardous materials involved in this situation? If no, it's not a problem. If yes, what kind of hazardous materials? Because depending on the hazardous material is dependent on how I respond. If it's a gaseous hazardous material, the last thing I want to do is introduce an aircraft into that, especially a turbine engine, because it, one, could ignite the flammable. Two, if it was not flammable, let's say it's a nitrogen leak, that could actually starve my engine of oxygen and I could lose power. If it is a powder dispersant that is poisonous, if I introduce a helicopter, all of a sudden now I'm spreading that all over the place. If it's a hazardous material of a radioactive material, I had a situation in Florida when one of our crews went and picked a patient up and it was a dump truck accident. Nobody thought that there was hazmat material involved. The hazardous material actually was the dirt. They were cleaning up a Superfund site and they were walking through it all day long. Got in the air and next thing you know, they got a phone call. Hey, don't go to the hospital, go to the decontamination site we're setting up right now at the airport. So When you get notified, you need to figure out what it is, how much it is, and what are the precautions you need to take. Keep in mind that if you have a contaminated patient, you want to decontaminate that patient before you put them in a closed space. Confined spaces with patients and hazardous materials don't mix. We've had incidences where flight crews, pilots, nurses, and medics have become overcome because of a hazardous material introduction. A good example of a hazardous material that is out there is if you respond to somebody that blew up their meth lab. Basically, every chemical that is used to make meth will kill you, and certain chemicals will kill you faster and than any of the other ones. So before you bring a patient on board, make sure they're not contaminated. If they are contaminated, take the proper protocols for decontaminating them. If by chance you load a patient that's contaminated and find out later, don't take them to the hospital directly unless they set up a decon site at the hospital for you. 9 times out of 10, they're going to have you land someplace else. And that's a fun exercise. Now, the landing zone itself, what makes for a good landing zone? In our eyes, we're looking for an open area that's got enough room for the aircraft to allow for proper maneuverability in all wind conditions. You don't want it so tight that if you blink the wrong way, you're going to bump into something. So clear of obstructions, clear of debris, and as we said, not so close to the people in the accident site. One, the debris field of the accident site, but the two, anytime you have an accident, it's a magnet for people. You'll see people show up that you didn't even know existed to see what's going on. So you don't want to bring the aircraft in too close. We want security, but it's not so far from the patient that we have to trek the patient out and cause injury or harm to the patient by trying to do that. If it's a hazardous material situation, distance will be dictated by the protocols of hazmat operations. I've done a couple, not very many, but we've had to move the patient upwards of a quarter mile based on the fact that it was hazardous material. So all these things are negotiations you're looking at. The ground should be as level as possible, and you should always try to get a long axis into the wind so that you can benefit from that performance increase versus the negative of trying not to land into the wind. Some of the things you look out for is if it's really wet and if you're going to sit down, will you sink? If it's snow, how deep's the snow? If I sit down, will the aircraft break through? Is it ice? Will I spin if I turn off too quickly? And in a helicopter, you have to be careful because if it's got one rotor turning, you have a manifestation of torque. And if I turn the motor and the engine off too quickly, the reduction of torque is too rapid. The skids may break loose from the ice and I'll start spinning. If I add torque too quickly, I may start spinning in the other direction. So you have to be cognizant of that because it's going to have an impact on how you do operations. Mind the critters and the livestock. I've had my fair share of encounters, never with a bear. Landed on a rattlesnake once. He didn't like it, and I left him there because he was stuck under the skid. We had an incident in the military at night at 2 o'clock in the morning. We were doing operations and stampeded 40 alpaca off the side of a cliff, and the Army wound up with 40 alpaca. Cows can be rather cantankerous. When you invade their territory, they may take a disliking to your aircraft. So you're doing that high recon, you're looking for these people as well, because one, you don't want to cause harm to the livestock because you're going to be paying for that. Two, you don't want to piss off the livestock because they're going to potentially damage your aircraft or could actually injure you. And I've never heard of that happening, but I know a couple pilots who've come close to that happening. Now, you get out there, you go to the patient, and now you're dealing with what we refer to as a mission change, or in this case, destination change. Be prepared for something not to go the way you expected it. So preparing for a destination change, that could occur because of patient condition. You go out there and you think you're picking up a very stable patient, you're going to take them to X hospital. And you get there and it's like, oh, this patient is extremely critical, unstable, and the hospital we were going to is not equipped to take care of that bad of a patient. We need to take them to a level 1 trauma center, not a level 3 trauma center. Patient needs to go there for a higher level of care, i.e., you're going to a different location. Be prepared to be able to identify really quickly what your capabilities are for range. And do you have enough energy or fuel to make that trip? So you've already done that before you show up, and you're looking at that before you even see the patient. If the injury or the ailment is such that location you were going to take it to was not capable of treating it. Cardiacs are good, strokes are a good example. You get into a situation where that patient would be better served at a different facility. So you need to make sure that you're able to adjust. You know what those facilities are. The facility you want to go to may be the appropriate facility, but maybe it doesn't have any the assets available, or the asset you need is out of service. We need an MRI. Well, our MRI is down for maintenance. We need to send you to another location. The hazmat we talked about, if you have hazardous contamination, you take off and you find out, oh, by the way, yeah, he's contaminated with X, Y, and Z. Oh, don't land here. We're going to send you to the airport. We're going to set a hazmat team up, and we'll deal with it there in a open, confined, uh, safe space. And then, of course, weather. Weather is always going to change. So you're always looking to see what the forecast is. In the EMS world that I've lived in and grown up in here in the Midwest, the average transport time for a patient is roughly, or was when I was doing it, roughly 28 minutes. So that meant 28 minutes out, 28 minutes back. That was the average. We had some hospital that were upwards of an hour to hour and 10 minutes, but on average it was 28. Now, some locations are much lower than that because densely populated areas, a lot of congestion. Cincinnati was a good example. A lot of their transports were off the interstate, but they may have only been 8 to 10 minutes. The farther the distance, the more the weather plays a factor. And you have to look at the window you need. So I'm going to go out. How long does it take to go out? How long am I going to be on the ground? How long does it take to get back? What's the window? And I look out in the forecast and say, this is the window I need, and this is the buffer I hope I have. So I'm usually saying for 28s, I'm looking for an hour window. Now, once I get beyond that hour window, what's the weather looking like? And I have to pay attention to where it's at, where it's moving, and how it's coming. Because now all of a sudden, if I'm stuck there because of patient condition or because of extrication, and that weather changes, again, I may have to deal with a destination change. I may not be able to go back where I came from, or may not be able to go and take this patient where they need to go. I may have to make a decision on, hey, do we still fly the patient, or we send the patient by ground? Remember the first thing, do no harm. What's the best for the patient? And that's where we get into a decision-making matrix. Okay, this happened. It's going to take us 40 minutes now to get that patient to the other destination by air because we can't go to the one we want to by ground. Well, it's only going to take me 15 minutes to move that patient by ground to that destination. So put them on the truck and get them to go in that direction. An axiom we live by in aviation, we also live by in the military. To go faster, you must slow down. If you are doing this project, make sure that you do the research, make sure that you practice, make sure you do tabletop exercises, and make sure you start playing with all the different possibilities of what could go wrong. Have something as an option. So we look at, hey, if this happens, this is option 1, option 2, option 3. If that happens, option 1, option 2, option 3. And play those scenarios out. We do that as a tabletop exercise. When we're working in the aeromedical industry, we debrief flights, what went right, what went wrong. We do what we refer to as hangar flying all the time and say, okay, what would you do in this case? What would you do in that case? And we're always constantly looking at the what if. That way, when the what if happens, you have a plan. But at the same time, you're not trying to make it up, because when you're trying to make stuff up on the fly, you're trying to go too fast. That's usually when something bad happens. And it's more apt to introduce air. So go fast. You want to slow down. Now, questions. I'll open it up to questions. Covered a lot of territory. Again, a very high level overview, but at the same time, these are the basics that we teach all the pilots that fly in EMS. It's like do no harm. We pay very close attention to who we're working with. We do training with them. We focus on the weather. We focus on the obstructions, and we make sure that if we see a problem, we circle until we figure it out and fix it. So with that, what do we have in the box so far for questions, if any?
All right, everyone. So just a reminder, please submit your questions in the QA box at the bottom of the Zoom screen. We will make sure that we get through as many questions as possible, but due to the number of people on the Zoom, we won't be able to have you ask them directly. Rex, to kick us off, what do you hope for GoAERO team? What do you hope to see GoAERO teams build?
No, I think in the GoAERO, the overall arching expectations on my part is being able to put something together that allows us to do rescue operations that, say, I couldn't do as a helicopter pilot because of the environment or the safety and the risk involved sometimes. There is also the capability of putting assets that are less expensive in areas that need them desperately. So when we're talking a helicopter, depending on what kind of helicopter you're talking, it's multiple millions of dollars. Crews, you got to pay them. You got to have a place to base them. This is an opportunity to put assets in locations that are in desperate need.
What are your thoughts on landing small single-person eVTOL aircraft in a suburban environment?
Um, it's a challenge in that do you have the performance to get in and out? If you're in a suburban environment, gets pilots in trouble all the time. If you're doing private operations, that's one box. If you're doing air ambulance operations, that's another box. And there's caveats in most ordinances that speak to that. If you're an air medical provider providing life-saving, they're going to let you do that. And they're going to let you land off-site. Now, the FAA allows you to do that through operation specifications. However, if you look at the regulations, there is a criteria that you're supposed to meet or an expectation on the landing site. Now, they'll say that the FAA says you can land anywhere you want to as long as you have landowner's permission. That is true at the federal level. You need to pay very close attention. What's the state regulations say? What does the state DOT have for that? Because they may say, yeah, where you're landing, and Florida is a good example of this. If you're landing on your property, it darn well better have a registered heliport. Because if it doesn't, you're going to get a letter of cease and desist. The other side of the coin is we'll go down to the next level. If you're an owner of property, you may have 80 acres and you go build a heliport. And I say this because I've had clients do this. And the next thing you know, you get a letter of cease and desist from the Planning and Zoning Commission. Because guess what? Your land isn't zoned for a heliport and you didn't follow the proper protocols and procedures to get a conditional use permit to do it. So there's 3 levels of bureaucracy that we need to pay attention to: federal, state, and local. The federal's the easy part. The state's a little bit more challenging depending on the state you're in, but it's the local piece that you've really got to pay close attention to. And then what do your neighbors think? That's the other piece of this. If you go in for a planning hearing, well, guess what? That's an open hearing. That's an open meeting. All your neighbors can come in there and, say what they think and tell them that they don't want your little landing area. And if it's in a state like Florida, California, or Illinois, you're going to be required to have a license to land on that site, period. So it's doable, but at the same time, there's hurdles and roadblocks and speed bumps that you need to be aware of. Next question.
Yeah. From a safety point of view, how might protocols change or become complicated by autonomous rescue?
Um, I think one of the key elements in the autonomous piece that we have a pilot on board that is trained to evaluate risk and analyze that risk on the fly. So how do we do that in the aircraft without a pilot on board? One of the risks I'd point to is the weather. How does my autonomous vehicle identify when the weather's changing and what impact that change is going to have on my ability to continue flight safely? Icing's a good one. That's been a challenge for us in aviation for a long time. But how does a either a remotely pilot or autonomous vehicle recognize the fact that it's occurring before it becomes a problem? Because in a helicopter, as soon as you get into ice, you want to get on the ground immediately because you're not going to stay in the air very long. And based on what I've seen so far in R&D with drones, uh, it's exactly the same, if not a little bit worse. So I think that's the biggest challenge is having a system or hardware or software that allows you to dynamically update your risk analysis throughout the process. I think that's definitely achievable, but it's not something that we have in place today.
Thank you. Um, as a specialist on eVTOLs, do you see any chance for all electric VTOLs to give air ambulance services? We know you mentioned the average flight time of 28 minutes, but the range and payload is a challenge.
I do. I think there's a possibility there for the shorter distances, possibly. I think in looking at the hybrid electric may be a great starting point for that. I think one of the challenges we run into if working in the helicopter world is going to be an equivalency. When you get a patient, especially one that's going between hospitals, they're usually in some cases a significant number of pieces of equipment that are keeping that patient stable or alive. In a helicopter, we have a turbine engine driving a generator, providing 110 volt AC on the wall that I can now plug into and run all those different pieces of electrical equipment. And the last thing you want to do is run on the battery of the equipment because once you get to the site, you're relying on that battery to be enough to move that patient to its final destination. You don't want to use that in flight, and if you don't have to. So we're always plugging equipment in. So if it's an all electric vehicle, what are we doing to run that equipment? A good example of a major consumer of electrical power in the helicopter would be a neonatal transport for a newborn, because we're using a warmer. We're using an isolette bed that's got multiple pumps on it. It's also got a heart lung machine on it. It's also, it's sucking up a lot of energy. And I've had it where the batteries on those things, we unplug it, put them in the ambulance and head out, and all of a sudden we'd run out of power and we'd have to plug it back into the wall in the ambulance. So that's, I think, one of the biggest challenges going forward is what are you doing about the ancillary equipment necessary to stabilize and keep the patient alive, because that's going to draw power and that's got to come from someplace.
All right. What did you wish you had access to when you were an air ambulance operator?
There are a lot of things I wish I had. Um, I think when I was doing, we saw the evolution of the navigational systems, which were huge. I remember I first started out, I didn't have anything but a map. Then we wound up going to the Loran and then the GPS. I'm that old, yes. But I think onboard systems that provided better real-time weather. We started getting weather into the cockpit, but it was always and has still been somewhat, what do I say, old information. There's a latency in there. We'd really like to see more information in the cockpit that was more up to date, more in sync with the actual environment. 15-minute latency is pretty significant in certain weather situations, and pilots have gotten themselves into trouble trusting the weather they've seen on board the aircraft. So I think that's one. Um, I think when I looked at from a safety person and a risk management person, I work in the safety management side of the house. When we do a risk analysis, it's a very static risk analysis. We do it based on the availability of the information at that moment. My goal in life is at some point to see a dynamic risk analysis that's constantly being updated based on what's going on minute to minute. So when the weather changes, for every hour the pilot's on duty, for every hour the aircraft gets closer to maintenance, for every change that's out there, there's something keeping track of that and actually adjusting your risk and informing all the operators involved so that better decisions can be made. And in that way, the expectation is you would actually reduce the risk and hopefully reduce accidents and liability exposures.
All right. Um, how much is a weight requirement for a patient when you design an air vehicle to carry patients?
Oh man, you're going to make me go down a very politically insensitive road. Um, Back in the 50s and 60s, when we came up with the quote average weight of the average person, it was around 170 pounds. Now, today, that doesn't hold true. Our lifestyles have changed that number. I have been lied to by the best of them because doctors and nurses at receiving or sending facilities know what my weight limitation is. I have transported infants that weigh 1 to 2 pounds. I've transported individuals upwards of 500 pounds and everything in between. Each one carries with it its own challenges. In designing a vehicle to transport a patient and figuring out what the best weight is, I would say on the low end, based on demographics that I'm aware of, the goal would be 300 pounds and below. That would give you a pretty good lion's share of that demographic. Minimum, I would say, would be 250, but 300 and down. There is that next level up that we get into, and even some of the helicopters that I operated were incapable. And a lot of it comes down to available space in the aircraft to take care of the patient well. Um, there are specifically designed ambulance services that specialize in that world. So it's not that we don't have something, it's just that the weight would be such that we'd never be able to design an aircraft to do it and do it at a rate at an affordable rate that anybody's willing to pay for. So I hope I answered your question there.
And just to add on to that, in the GoAERO competition, the Alex mannequin that will be part of the competition is 125
Right.
pounds.
He's a
Uh,
he's a lightweight.
what specific aircraft features have made your tasks easier and which have made them harder?
Aircraft features that made it easier. Excellent question. I would say, the dawn of the turbine engine definitely made things a lot easier for us because we were able to um, have a consistent power in different elements of density, altitude, and temperature, and be able to perform better. Um, other things in the aircraft, I would say navigational systems definitely help significantly. Being able to rely on a good, strong nav system that would also not only tell you where you're going, but also what to avoid. So airspace. I work in an area that has a lot of restricted airspace and military training areas. Being able to have that up front and not have to keep an open in a map was, yeah, that's a huge help. Um, on the negative side, what's been a hindrance? Oh my. I would say the one thing that's yeah, I see, and this is something that we dealt with in the older engines, like the Allison 650s and 750 engines that I worked on. You had a 2-minute cool down. So 2-minute cool down meant you land, you shut the engine to idle, wait 2 minutes before you can then shut the engine off. Newer engines is 30 seconds. With the advent of electric aviation, there is really no cool down. You on and off. I think that shrinks that time frame down. So sitting there waiting for that engine to cool off so you can shut it down is always like 2 minutes was agonizing. So I'm sure I'd think of a lot more, but I don't want to waste time having you watch me think of them.
In an emergency, what constraints or steps have you waived to best serve the need?
Say that one more time.
In an emergency, what constraints or steps have you waived to best serve the need?
Um, well, I will say that if there was an issue, we'd always try to err on the side of safety. We would not go out of our way to do something that was against a protocol. And it's really important that you have a policy and the protocols in place for that decision making. One of the problems we found in the early 80s when we started really getting into the aeromedical industry was pilots were negatively influenced in their decision-making process by certain things. Pilots don't get information on what kind of patient they're going after. All they know is they're going to X location and they're picking up a patient that happens to weigh this much. That's what they're basing their decision-making process on. Um, so there's been times where I've not taken the flight because of weather, and we've had to, tell them, yeah, you're going to have to send them by ground because the weather's not safe. Um, that would be the direction that we had. We don't waive any of the protocols or procedures when it comes to flight safety. They may waive protocols and procedures for actual medical care, but not for the flight safety. And we've gotten really good buy-in from the medical professionals in the industry to make sure that we keep each other honest in that space. So yeah, I can't think of an opportunity where I've said, yeah, let's go ahead and do it and see what happens. No, it's usually when we hear those words, that's usually when we say, okay, stop, somebody's about ready to die.
Um, has every mission required a game time change?
Has every mission required what?
A game time change.
No, there's a lot of times you go out and it's exactly what you thought it was. It's the problem is in that you get complacent if that you experience that so many times and all of a sudden, boom, you get the change. Um, and that's probably why we beat it into pilots' heads so much is, hey, this could happen because it's when it's least expected and you put yourself in a situation where if it happens, you really don't have the option to deal with it. And that's where we see pilots getting into issues or operations becoming higher risk is we always are trying to think about the what if. So when it does happen, we have an option. If we're not thinking about it, and a lot of times it doesn't happen, but you're always thinking. It's like we teach pilots when they're flying. Is like, okay, if you had an engine failure right now, where would you go? All right, if you had an engine failure right now, where would you go? All right, if you had it, and it's constantly you're getting the pilot acclimated to the what if. It may only happen once every 100 flights, but it does happen, and you always want to make sure that when it does, you have a plan of action already thought out in your head, so that you're not trying to figure it out on the fly.
Okay. For icing hazards, are there de-icing systems and components that are available on the market?
There are some. The challenge you run into is complexity and functionality. There are only a few helicopters in the marketplace today that have what I would consider optimum anti-icing and de-icing equipment. So if you look at the Super Puma, you look at the design of the S-76 Delta model, and then you look at the military's Black Hawk for the Army, the Jayhawk. Um, yeah, Army, Coast Guard, Air Force for the Pavlo. They have icing, de-ice and anti-ice capability. Now that said, the average helicopter pilot, even with that, doesn't go intentionally flying into icing. It's more so that they can get out of it if they get into it safely. If I've been in icing 3 times in my life, couldn't get on the ground fast enough. I think the challenge you run into is you need something to be able to produce the anti-ice and de-icing capability. And that something is usually energy. So in a helicopter, you have the bleed air on the turbine is pulling the heat off the turbine directly, which is then feeding into a mount support in the engine compartment for the front inlet vanes. And that is actually pumping hot air through there. So if ice does accumulate or starts to accumulate, it can de-ice that. The blades in the Black Hawk are heated. That's being produced in, I think, most cases by electricity. Now, you don't have a turbine engine on an all-electric aircraft, and the last thing you want to do is add another consumer onto an electric aircraft. So where are you getting the energy? There's research being done in that space, but as to this point, I have yet to see anything that has been that functional that would say, hey, I can take this aircraft and fly into icing and de-icing an aircraft like a in the 121 market. So you go to an airport, you get on Delta or American, and you jump on an aircraft and you go through de-icing. That's not to stay in icing. That's to get through it on the way up to clear airspace. The aircraft that we're talking about aren't going to fly above icing. They're going to fly in it. Same as me as a helicopter. So yeah, it's going to be a challenge. There may be some opportunities down the road due to new technology that allows for it, but as of right now, there isn't anything on the market that I'm aware of that would probably allow this because, yeah, I could put heated blades on my electric aircraft, but I got to power them with something that's going to really significantly impact my range.
All right. And our last question, what additional awareness or sensors would you want available on missions?
Um, I think situational awareness. I think one of the things that I see that the UAS and drone community have that I'd love to see on helicopters today is the ability to sense and avoid. So when you see some of the sensors that we're now seeing deployed on uh, DJI, Skydio, um, drones like that, that don't won't allow them to run into something. Not, of course, at high speeds, it's not going to work nearly as well, but at low speeds, when you're shooting an approach or on takeoff to keep you from bumping into something, I think that would be a fantastic add-on to the helicopter industry. I think I think there's opportunities from the weather side to actually outfit the aircraft with more sensors that would, if you look at these aircraft flying in urban environments, if I had 30 aircraft operating in an urban environment that were all outfitted with the proper sensors, I would be able to map out the microclimate on a minute to minute basis, and I think that would be huge. And being able to have real time observations that then would provide the pilot or the operator with actionable information.
All right. Well, thank you so much, Rex, for your time today. And thank you, everyone, for attending the GoAERO Expert Lecture with Rex Alexander. We hope that you tune in for our next lecture, and we'll see you all soon. Have a great day.
Well, thank you and take care.